All right, so we're going to answer the question today of how do we solve a system of equations by graphing? And specifically, we're looking at systems of linear equations. So first of all, what is a system? A system is just whenever you have two or more linear equations, and their solution is any ordered pair, xy, that satisfies each equation. So for these two linear equations, y equals negative x over 2 plus 4 and y equals x minus 2, this point right here at 4, 2 would be the solution. So that just means that if you were to plug in x equals 4, like a 4 in for each of these x's, you would get that this y is equal to 2 for both equations. So their intersection is the solution. All right, let's try to do an example where we solve these by graphing. So here we have two linear equations, 4x plus y equals 8 and 2x minus 3y equals 18. We can do this in a number of ways. Let's just solve each of these for y equals. So in this first equation, y equals negative 4x plus 8. And we're going to graph this. This has a y-intercept of 8 and a slope of negative 4. So we go to 8 on the y-axis. This has a slope of negative 4, so I'm going to go down 4 over 1. Down 4 over 1. Down 4 over 1. And just keep doing this. I'm going to connect my points. Okay, in the other equation, 2x minus 3y equals 18. I can subtract 2x from each side, so negative 3y equals negative 2x plus 18. Then I'm going to have to divide everything by negative 3 to get x, or to get y by itself. So y is equal to positive 2 over 3x minus 6. So my y-intercept is negative 6. My slope is positive 2 over 3, so I'm going to go up 2 over 3, up 2 over 3. And here we see these two lines intersect right here at 3, negative 4. So our solution to this system is going to be 3, negative 4. This point satisfies each of these equations whenever you plug it in. So 4 times 3 is negative 12, plus 8 is negative 4. And same thing works over here. All right, so now it's time for you to give it a try. We have two equations here. Just go ahead and press pause, and then check your answer in just a minute. All right, once you graph both of these equations, you should see that they intersect right here at 0, negative 8. So my solution to this system is 0, negative 8. Okay, so now that we see that the intersection of these lines is the solution, let's dig a little bit deeper in classifying these. First is, what makes a system consistent? A consistent system has at least one solution. So if a consistent system has at least one solution, an inconsistent system must have no solutions. Okay, and those are the first ways that we would classify a system, either consistent or inconsistent. The next would be independent or dependent. An independent system has exactly one solution. So only one point of intersection, exactly one solution. And then a dependent system has infinitely many solutions. Infinitely many. Okay, so now that we have these definitions, let's see what that looks like on a graph. Okay, so with two lines, we're going to have three different ways that these solutions could occur. If I just have two lines like we've seen, where they intersect once, this would have exactly one solution. And because it has exactly one solution, since it has at least one, we know it's consistent. And because it's exactly one solution, it's independent. The next would be if we had two parallel lines. Parallel lines will never intersect, so these have no solution. Parallel lines are inconsistent because they have no solution. So they can't be independent or dependent because they don't have any solutions at all. The last situation is if you had two lines that were lying right on top of each other. These two lines are just always intersecting, so these have infinitely many solutions. These lines are consistent because they have at least one solution, and they're dependent because the number of solutions is infinite. All right, let's look at an example of a system with infinite solutions. So here I have 4x minus 3y equals 8, and 8x minus 6y equals 16. So let's solve each of these for y. We have negative 3y equals negative 4x plus 8. Divide everything by negative 3. We have y equals positive 4/3 x minus 8 over 3. Now, before we even graph this, because it might be a little difficult with this negative 8 over 3, which is about negative 2.6 repeating, let's look at the other line. If I solve this for y, I have negative 6y equals negative 8x plus 16. If I divide everything by negative 6, I get y equals 8 over 6 reduces to 4 over 3x, and then 16 over negative 6, well, that just reduces to negative 8 over 3. And then, as you can see, these lines are exactly the same. If you ever end up with the exact same line, then these have infinite solutions. And whenever you graph both of these lines, you're going to end up near the same, not near the same, but the exact same line. So we start with our y-intercept, and we'll go up 4 and over 3 from here. So we'd be at about 1.3 and over 3. And we're just going to have the exact same line lying right on top of each other. So this is infinite solutions. Finally, the system with no solution. So we talked about systems with no solution are parallel. And to be parallel, you have to have the same slope, but different y-intercepts. Anytime that you just solve these for y and you have the same slope with a different y-intercept, you know that there are going to be no solutions. So let's look here. Y equals negative 2x plus 4. And in the other one, y equals negative 2x plus 1. So these two lines have the same slope, but different y-intercepts. And on a graph, it would look like this, plus 4, and then minus 2x would be down 2 over 1, down 2 over 1. We draw a line through here. Our other line is negative 2x plus 1, so there's that 1, down 2 over 1, down 2 over 1 for our slope. These lines are just always going to hang out right next to each other. They're never going to intersect, so these lines have no solution. All right, and that's how we solve linear equations by graphing.